I'm going to demonstrate how to spot and develop a TLC plate and then how to visualize using ultraviolet light. You'll need a few things to get started. TLC plates, TLC spotters, a TLC cutter, a solvent chamber with a piece of filter paper, a 10 ml graduated cylinder that can be used to prepare your solution, and whatever solvents that you need to make up your solution. You'll also need dichloromethane to dissolve up your samples. We're going to begin by preparing a 1 to 5 solution of ethyl acetate to hexanes, and we've already tested this and determined it gives a good RF value for our product and starting material and separates them adequately on the TLC plate. You may have to make many solvents and try various conditions for developing your TLC plate. Using the 10 ml, I'll fill just up to the 1 ml mark with ethyl acetate, and then I fill up to the 6 with hexane, so a 1 to 5 solution is prepared. I can now pour this into the solvent chamber. We add a piece of filter paper. This is to make the solvent in the chamber uniform throughout. Be sure to close your jar tightly so that the solvent doesn't evaporate. If you have a solution of ether hexanes, the ether will evaporate much more rapidly from the hexanes. Thus, a chamber left open can actually change concentration over time. I'm now going to prepare the samples to spot on the TLC plate. You'll note that I have one vial and it's labeled, it says SM. That stands for starting material, and this is the starting compound of the reaction. Here I have an oily mixture from the reaction, and we're going to spot both of these on the same plate. We first need to cut a TLC plate. In this stream we use the glass back TLC plates. Press firmly, score the glass, and with your fingers flat, break the... You'll need a pencil, preferably a dull pencil. We're going to make a light mark at the bottom of the plate. We'll make 3 dashes. One is for starting material, one is a co-spot, and one is the reaction. It's important, even if your material is a liquid, to dissolve it up in dichloromethane. This would make a very concentrated sample, and if the spot is too concentrated on the TLC plate, you may not see separation at all. You'll just see a big blob. We're going to add in dichloromethane to make a solution and dissolve our solid. I'm also going to add dichloromethane into the oily reaction mixture. To spot the plate, the starting material is spotted on the left and also on the middle spot. If my compound is UV active, I can test the intensity of the spots using UV light. From this TLC plate, it's clear that I spotted enough of my sample. I'm now going to spot the reaction mixture. And I spot that one on the right, and I also spot it in the middle. The co-spot is important to show minor separations. I'll again check the intensity of my spots. And you can see my reaction spot is a bit more intense than my starting material. That gave me a nice preview. I'm going to go ahead and spot just a little bit more starting material so the intensities are similar. We can now stand the TLC plate carefully in the chamber. And again, close it tightly. Now, it's important to know that your TLC plate may fall over your first time. It may fall over several times, and don't get discouraged. It takes a lot of practice to be able to do it on the first time every time. I have many years of practice. We need to remove the plate from the jar before the solvent front gets to the top. Remove it and quickly draw a mark to indicate the solvent front. This TLC plate can be visualized using UV light, and from this TLC plate I can see that there's a new product in my reaction. However, there's still a little bit of starting material or something that has the same RF of the starting material.